what I would love to do is like here, the topic is like the token optimization. What's the problem you guys are facing? Because there's a bunch of different ways that we can go. I'm from the infrastructure side, so it's sort of like on the infrastructure optimization side, and we brought in some guests who are like different parts of that stack. But I don't want to go off on these tangents, so I actually would like to hear from the people who came, what's the thing that's most valuable to you, or the problem that you want to solve, or you're just interested in, just so I can make sure that we oriented everything. If we could maybe, because this is so small, if we could hear. It could be an overview, hey, I'm just curious about the whole space, or it's like, hey, this is kind of an area of why we're concerned, and that would start there.
I guess for me, I don't know which models to use, so I just assume as a non-technical user, Fable, let's say, it's gonna be the best model, and I'm just using it, and I get a slap from my CEO saying, that should be what the developers are using, not you go to market, like.
Oh, really?
Like kind of thing. So I just don't know. Okay, is Opus good enough? Should I go to? I think Haiku is like maybe the step below, right? To me, model's model, I get outcome, right? And I'm just like, well, I want the best intelligence for my question. I'm always going to be using token maxing, right? That's the whole premise of this. I'm just using the highest one, so it'd be interesting if you guys have a perspective.
Is his concern a budget concern?
It's a budgetary concern.
Okay.
That's the big issue, right?
Okay. And did he ever say open source was out of the question, or we should incorporate open source, or what was the?
No, we're definitely evaluating open source.
Okay.
Yeah.
Okay.
I think we're pretty early still in the journey.
Okay, cool. Yeah, that would be something that we would do. What would be your interest area? Or are you with one of the?
I'm with Daniel.
Oh, okay. Then let's proceed to something. What would be something that you'd be interested in?
So I am not from the startup side.
That's fine.
I'm more from the investment side.
Oh,
So
okay.
I'm really curious, like, overall, how to make the token more efficient, like how to better use it. So like when the founder talk to me, I understand more.
Okay, great.
So for me, it's like
overview.
everything, as long as I understand, I can listen, I'm happy to do that.
Okay, great, super, awesome, great, thank you. And then I think the rest of you guys are all tandem, right? Okay. Hi. We're just looking. What's the thing that you're kind of curious about? It could range from very specific areas if you've been working on the problem area, or you just want an overview, or just like that's kind of like.
I would say I would really want to hear from your side, like whatever you guys are dealing with. So, like, I'm working on an infrastructure for people building their agents. I think most of my clients are pretty small, so they haven't really got into this point where they need to actually say crazy amount of tokens. So I want to hear what are the problems in a bigger scale.
Okay, great, cool. So we'll do the intros on how we approach that, and then we're going to start diving into some of the questions. So I'm from Aurora. We put this together, and so I lead product around, and it's basically infrastructure. So we have as a premise that the GPUs, as you know, is the scarce part, and that's where we have access to that. And so we're able to reduce the cost because there's no middleman. But it also means we're working from the GPUs right now up to the model and the inference serving. And so all the optimizations take place kind of like in the infrastructure, in kind of like we normally have a layer cake that kind of like shows, where in the layers are we finding stuff. So there's some at the base layer that there's not much that you tune. It's just what was the cost of the GPUs, what was the power, and the overall capex of the data center, and that actually is a factor, which is why it's made the news. But everything else that we look at in terms of how we, for example, handle the caching, how do we do speculative decoding is one thing that, like, for example, as we go into inference, we're like working on those things. So we're really kind of like talking about layers of the stack, and we can talk about some of those further on in the discussion. So that's where we come from.
Nice. I'm Giacomo. You can call me Jack. Usually it's a bit easier. I'm the founder of Rato. We do context infrastructure for production agents. And we like to say production agents because there's a lot about context engineering, which is just about engineering what enters into a context window of a large language model, which ultimately decides, what it outputs, not the quality of the outputs. And when we talk about context engineering, there's a lot a lot of shades to it. There is what we can call like an ontology, so like everything that the agent should know about a specific data point or person. So let's say within a company you can pull together different data points, resources about the employees, and then whenever you ask about, oh, what do you know about Jack? And he knows everything about me just because he pulls data from different document sources. And then it's about what can you feed from outside of the organization, so like MCPs of like Gmail, Calendar, and all these things. And what we focus on is mostly like the internal capabilities of the agent. So the moment you build an agent that goes into production, that can do certain actions through APIs, through MCPs, through skills, we make sure that at every turn of the agent only loads in the context window the tools and skills and eventually the memory that it needs to perform the specific action. And we do this because you pay those tokens. You pay them an input and you pay them an output. And token optimization is not just the cost, but it's also the reliability. Because when turn by turn you use an agent, multiple times, and you start separating your context window beyond 20%, beyond 40%, you're quite sure that your agent's gonna start fading at some point, right? So that's where we're positioned with Raytel and open source. So.
Hey everyone, I'm with Tandem, and we kind of want to sit between the users who want to access the models and between the actual hardware itself. We know that the main problem, GPU is a scarce resource, and it's available in so many different places. AWS has some, which we can get capacity to. Your Neo clouds have some. People have on-spots and even reserved instances, and all over the place. The compute space is very fragmented. So Tandem wants to ensure that any model, be it DeepSeek, Qwen, OSS, OpenAI, we want to deploy that specific model based on the specific job requirements we have. If some user's job is only going to run online, the optimizations we can do for online jobs, like a chatbot, are very different than what we need to do for a long document analysis. And they require different hardware. And even on the same configuration of hardware, for example, let's pick 8 H100s, the way I place the model on those H100s can drive my tokens per second anywhere from 200 all the way to 1400. That's 1,200 tokens per second difference if I don't place the model on the GPUs correctly.
Yeah.
So Tandem's job is to act as a cluster manager. For example, for the users, we want to find the best placement for a single job, for every single job in the user's cluster. And we want to do it on a heterogeneous set of hardware, not only NVIDIA, but also TPUs and AMD. And we want to do it on a mixture of on-prem plus clouds, and different market types as well, reserved and on-demand. And we want to make sure we get the best dollar per token, best TTFT latency, while being within your SLO, or leaving your system.
Yeah, cool. So, I'm gonna start phrasing some questions and things that we've heard, and also based on what you've heard. One of the things that, for example, from our perspective with customers has been, hey, I'm already fully baked on Anthropic or OpenAI, but I know I don't need all of them. Like, I think we have a good example. How do I, then optimize the quality of what I'm getting? I might be on Fable. I don't need that completely for, some more routine tasks. How do we, put that over onto, an OSS model that's hosted somewhere else? What do you think is like, from your perspective, the challenge, and how you guys can help to address that that cost preservation? Like, our first thing was like, well, the mere fact that you're on open source would be cheaper. But on our end, we also are facing kind of like a, hey, but we have a ongoing running cost of having a GPU that's not being used. And so if we don't have it fully utilized, like, we're running at a loss. So we can always quote a low cost to them, but internally we have to manage what is our real cost to the customer. Like in some ways, we're not VC funded with hundreds of billions of dollars to subsidize other people. We actually have to have a lower cost, but it's fully funded. Maybe what's your thought on that, and then we can piggyback a little bit on what's that real cost from both the provider perspective and then for the end customer. How would you end up solving for that, or addressing some of that? Because you're kind of getting at the where do you put the workloads in your orchestration.
Right, so we were talking to a bunch of enterprises.
Yeah.
One of the issues these large enterprises are running into is they have more jobs. And these jobs vary from not just inference but also training perspective.
Yeah.
And now you need to manage a couple of different jobs, which are very different SLOs, all on the same hardware, right?
Yeah.
And the biggest challenges are with SM utilization. People don't realize that, okay, specific parts of the inference, prefill is compute bound, and decode is actually memory bandwidth bound. So I can separate out those two phases, and I can utilize some GPUs. For example, H100 is awesome for prefill heavy tasks, but maybe a Trainium or inference chip or some NPU or lower end GPUs are okay for decode tasks.
Right.
So I don't have to use the same type of hardware for all the different capabilities. And people have been experimenting with prefill and decode disaggregations for a while now. And also, people don't realize currently, is like you mentioned that, okay, we're going to use Fable. For the model provider side, from you guys' side, what GPUs even pick? What GPUs to buy to put that model on, right? People currently in a lot of enterprises, they're reserving hundreds of H100s, hundreds of B200s on AWS. But when they actually run into and utilize, one of the people I was talking to from SSNC, they're doing a lot of document processing, and they're not getting good SM utilization. They're not getting good memory utilization. The actual kernels and attention layers built to solve these inference providers. For example, VLM and actually like they have decent optimizations internally to run a singular model on the hardware. It's on us on how we place this hardware. So the way we have defined our placement strategy is we want to follow a story. What I mean by the story is I care about dollar per token, I care about throughput, I care about latency, but that's a factor of time I spend in network, time I spent on the pipeline bubbles, time I spent on KB hit rate, etc., etc. LM Cache is another open source software I want to point out where we can reuse a lot of the cache so we don't have to compute it again. And all of that is a factor of which models I'm using, which characteristics of the model there exist, and also the hardware characteristics I'm deploying it on. So in our sense, if we can figure out the story on what leads to what, that ultimately leads to my performance, and I can figure it out for many different scopes, small models are different than bigger models, there's a mixture of experts models, then in theory I can do joint optimization on every single placement I make. So our goal is to find out that causal graph story, and then we run a lot of evolutionary algorithms within to find the best placement. But there's, just in our algorithm today, which is in beta, there's more than 140 variables.
Yeah.
For those variables, there's different degrees of parallelism you can use, and the search space just blows up. And no human manually or an algorithm just goes through every single one can do. Maybe that will work for a single job, but with multiple jobs running, it's just impossible. So we want to use some sort of domain knowledge, even using LLMs maybe in a way to find these placements, which have been benefited by a lot of research going on to make this happen.
So one question.
Yeah.
So do you optimize like on the more model and hardware level, or do you also like perform the routing? Like for example, him, right? That he doesn't know why using Fable or why using any other model. Like for the user perspective, would the model swap underneath, or you just stop at a certain level of the infrastructure?
And we're not focusing on switching routing or requests to different models.
Okay, so
But-
they don't compete.
It's the other way.
Yeah, it's the other way.
It's the model.
When you have picked which model to even deploy,
Yeah.
at one time maybe only one person is using it, and sometimes there's more. We can scale up and scale down the necessity. For example, at one time at 7 a.m., all your engineers came in and they want to use DeepSeek. But at 7 p.m., they got off, and some other market or some other people want to use a Gemma. We can swap those resources from the DeepSeek's resource placement that we're using and give it away to a different model.
Yeah.
So as long as we have a list of all running models, we can swap and place different placement strategies.
It's interesting because we see tomorrow like top of the funnel. So we like, for example, something that we're releasing now. It's say he's using Cloud Code or whatever agent that is can swap models underneath, and we recognize intent. We have like a model that extracts intent from all the sessions, consolidates, and then understands how difficult that skill is to run, and every time the user is performing an action that skill is required, there's already a model attached, and it already swaps the model. So you can really see, I think what's interesting about this is like, you guys are like foundation kind of hardware, like how to make every dollar count when the model runs, and we go a bit more about like when there's the user, and then the user can swap the model underneath.
And then the stack we're talking, you guys have the GPUs.
Yeah.
We sit very close to the hardware, right,
Yeah.
until the inference engine standpoint,
Yeah.
to the cluster management standpoint, and then any application layer can easily
Yeah.
come in and come in.
Yeah, and from our perspective, we want to work backwards from the customer. Like in some ways, your question of that the CEO is asking is why are you using this versus that, we actually are trying to set up a product that we should abstract that away. Here's your workload. Like it shouldn't, if it's a GTM related workload, it shouldn't be up to you to decide, well, which model is it. What should happen is what we're working on. There's a couple of ways to do that, and he's going to talk about it. It's like based on the complexity routing, so it like can do some kind of analysis of at the time of your request, this is the model that's used, and then we're working on either our own or with somebody else to like just show here was the cost and how we actually routed. So rather than you trying to say, well, I gotta use this model, but maybe for this I actually need to do this model. Like what happens if you misjudge, right? I mean that's costly too. Is just here is what the spend was and here was how the models were using. So it's actually putting various approaches to doing the routing. Before we go further, I wonder if maybe you could explain how, because I remember I got a little bit of into how you guys are doing parallelization in 3 different approaches, because that's how you're figuring out where it actually goes. I'm wondering if you could like provide that context.
Easy way to kind of understand this is you have open source weights and you have a bunch of GPUs. You have a resource map that you want to place everything on. A couple of ways you could do so. You can, if your model fits within one node, then you can put the model within one node. You can use something called tensor parallelism to split it across different GPUs in that node. If it doesn't fit in that one node, you have to go across nodes, and that's called pipeline parallelism. Mixture of experts models need expert parallelism. How many experts would sit on each GPU? Because that heavily influences the communication I need between each GPU. It's an end-to-end mapping for a mixture of experts. And most big models are a mixture of experts these days. And even when you have placed a model on a specific node or a specific set of GPUs, to serve a large number of people, you need to replicate the model. So you need some sort of data parallelism to replicate the model on different nodes. Beyond this, more optimization, parallelization techniques that began. You can do context parallelism, where you can know which context was sitting where. You can do beyond this sequence parallelism, how many requests to send to which one based on load. You can do routing also on terms of prefix. Hey, has my request been processed here? So I should send my user that processed the request on that same node, so I don't have to reprocess it. And all of these have different degrees. Tensor parallelism can go from degree 1, 2, 4, 8, depending on how many GPUs are in their node. Same for pipeline parallelism, can spread across. And data parallelism, you can do it across your whole data center. And it depends on the way you want to route them. So in our case, we have that burden of just for figuring out which parallelism to build for that specific model. And then also we have to build a global router, because every resource is not just on one cloud. If I want to route it to this node, I want to route it to a node in AWS, or a node in Aurora, a node in GCP. Which nodes in Aurora do I route it to? And that's the type of strategies that we're trying to incorporate and find out the parallelization.
One of the things that, for example, we're trying to do to like address the overall lower cost versus like a Fable is we're just letting the open source labs do it. So for example, GLM has made the rounds.
Beautiful.
So we started talking to them, but they were very specific about our configuration. They were like, it had to be SG Lang. How does your thing work? Like, is there some degree of freedom that gets taken away the more we double down on a model that reduces the degree of freedom that you have to give us the optimization? And then we would probably turn over for you for context. What happens to context if we are realizing, let's say he's running, he's like, okay, we're going to use GLM, but we also have something with Quen. Do the things break? Because when we talk, for example, to the GLM, they were like, hey, we're gonna have a very specific specification on how you set up your clusters and your frameworks. So does that reduce our flexibility?
I think it increases our flexibility in terms
Okay.
of a broader scope.
Okay.
The reason is, let's just assume 3 hardware types. We'll assume NVIDIA, AMD, and then we'll assume, let's say Intel for now.
Okay.
NVIDIA has CUDA. There's specific attention kernels built to support CUDA, flash attention, etc. The VLM uses, SGLang uses. There's TensorRT-LLM, which is another way of running inference engines made by NVIDIA. On top of these different engines, so now each hardware provider, AMD has built ROCm to some degree, and you have some attention backends that support that specific chip variable.
Yeah.
And we'll we'll give it to the actual hardware manufacturers. The NVIDIA will build the best kernels for NVIDIA. AMD will do the same for themselves.
Yeah.
Then you have different engines. You mentioned SGLang. In our case, and now VLM has VLM Omni, so they can support diffusion models too. But a couple months back, there was no way for me to run diffusion models on VLM. Not possible. So if I want to run diffusion models for images, I have to use XDIT or diffusers. That doesn't mean if my stack doesn't support XDIT, then I should be able to run it. So for us, we want to find out what model needs what inference engine. Loading up the inference engine on the specific attention mechanisms for that hardware is pretty naive. It's easy to do. And we want to figure out to find the best set of software that runs a specific model. So in the GLM sense, if SGLang will run GLM the best, more than VLM, then we will use SGLang. And if Quen is best run on VLM, then we'll use VLM. And even on top of them, there's a couple of, so I'm assuming everything's running on Kubernetes in this sense. And within a specific Kubernetes instance, NVIDIA made NVIDIA Dynamo, which is an inference runtime. Abrix is made by ByteDance, which is another inference runtime. And then there's an LMD, which is made by IBM and Red Hat. Right? These are all different inference runtimes that can utilize VLM or SGLang to route between them. But they're only specified and tied down to a specific set of Kubernetes cluster, right?
Yeah.
And
like we are constrained in some ways. Like we had to make a choice.
Right.
Dynamo and SG.
Right. But our sense is if Dynamo is not going to perform as well as LMD, or LMD is not going to perform as well as Dynamo on specific model, specific tasks, or VLM hasn't supported the model yet, but SGLang has, or none of them have supported the model, but Hugging Face's original TGI has, we will launch that up on the specific cluster and on Dynamo or LMD, and we will become the global router between every single runtime and hardware itself. So it gives us a lot of flexibility that no matter the specific model that user wants to run, be it diffusion, be it MOE or any other multimodal, we will find the best place for that to run in today's architecture, and we will make sure it runs on your specific hardware.
But so selfishly, let's say we want to maintain, hey, we're trying to operate and maximize our set of infra, and we know that we need to we're going to be pulled forward by users for the best performance and the best thing. Are we constraining ourselves in some ways because we only going to have the set of Kubernetes clusters for the node that we have, and only a number of models? But they're going to constrain. They're going to say, hey, you got to use SGLang.
But we can run SGLang and VLM in parallel. If we have two different models,
give us
exactly.
ability, sort of like you would help manage the cluster at that level.
So we want to become this global cluster manager, and you can totally run TensorRT, SGLang, and VLM in parallel on different.
As long as
models.
we have the hardware,
as long as the hardware exists, that supports that specific VLM or SGLang, we can split models and run them on the same cluster in parallel. So our whole cluster doesn't even need to be a Dynamo cluster.
It
doesn't need to be. Dynamo can only hold a specific part of the cluster, specific node, and we will distribute the rest on whatever infrastructure is needed for that cluster.
How about let's go back to the anchoring question for context. Let's say we're just saying, hey, we're going to abstract away the model for you, but at some point they have built up contexts that come in and their requests. But now we're going to be jumping. We might want to say we want to be jumping back and forth among different models. how do we sort of like handle that? Because that could become super inefficient. Like some of it might be like, and it might even break things. Like I was talking to one of the models around, well, what happens when you start doing that for cache? Like if you're switching models, the way it was cached wasn't like allowing you to like save on the GPUs for that. So on the one hand, you're saving by switching the routing for which model it is, but you're doing the cache. Yeah. So what's your take on that? Because you have the context level, I think you have the cache level, but context is like a big part of the savings for costs for them and accuracy.
And for performance, because let's say you switch, now for example, now we're releasing this little router for Cloud Code for them to play with, and we use it internally on like a GPU that we have in the office, and we switch model under Cloud Code, so you could be running Fable or like DeepSeek, and just trick a bit Cloud Code using that. The biggest problem, you also take Opus, you go from a 1 million token window to context window to like a 200K context window.
So your area of smartness shrinks.
Because we have this very hard rule to keep always context window below 20%. When it starts reaching 20%, we start compaction, we have our own compaction, and on a median token context window, that's 200,000 tokens.
Right.
And if you're efficient, still might take a couple of turns, depending on like how heavy your workload is to get there. But on an open source model, let's say there's 200K context window, then your playground is way smaller. So you really need to make sure you're not paying for the tokens, but you pay for the reliability. So for example, we run a couple of benchmarks. Since we're open source, we always push them out. And we saw on Quen, we run on Metatool, which is like a public benchmark of tasks. It's run like an agent that runs with 100 tools attached on, I believe it was 180 different tasks. And with Quen, you basically go from 7% accuracy without any context optimization to a stable 80% accuracy by using like a solution like us. Because basically, we just make sure to load everything, only the things that it needs. So for a task, you need 5 tools, I only upload those 5 tools, instead of just reading like the whole blank catalog that it does. And so in our way, when you go a bit above the stack, context is what makes the model actually work for the user.
When you said you are compacting after 20%, how do you make sure the accuracy doesn't go down in compaction?
So we give this, like we're trying different solutions on that. We started like by giving open, let's say, not weights, but like the ability for the developer to be like, okay, I just want to know the summary, I want to keep the most recent 5,000 tokens for that specific session. So depending on the use case, you can configure it. What we're trying now is some other open source tools, because compaction is not quite our core. Like if compaction is compacting what goes into the model, but you already selected, we are about like how do we select what goes to the model. Then you want to compact it further, great.
Are you guys for long horizon tasks or short term?
I did it for long horizon tasks because you keep accumulating context and you have to go back to that context.
So are you guys making some sort of tree to go back into workloads?
For the memory part, yes, but we haven't shipped the memory layer. We're just testing it internally through like graphs. Initially graphs and you through embedding to just connect things. But for us it's a lot about retrieval memory, so like you solve a problem type A, let's say, and you use like these 3 tools in the sequence. On the next time we're going to solve a problem type A, we're going to augment the score of the top K token or the top K tools that you're going to select for the task, right? So you don't always go and discover about like all your tool skill catalog, but you already know what you need to solve the problem.
So the benefit is you use less, but there will be some latency, like I said.
We try to, like on most benchmarks that we run with the same speed, but we don't optimize for latency. We keep latency stable and we optimize for accuracy and token cost. Like for example on like Opus and so on against the tool search tool of Opus, we don't do insane improvements of accuracy, just like a couple of percentage points, but we cut half of the tokens because we remove that out of the model. So you don't go ahead and close to do that.
On the input side, I mean, that's distributed, right? Okay.
Yeah.
I thought maybe I would get a little more context from an investment side, like you're looking at founders and trying to figure out what is it? Is it like how they're efficiently using AI for their startups, or what? When you said you wanted to kind of know, like as an investor, when you have startups come in, maybe you can help me frame what you're looking for. What's helpful on that side?
I try to understand what is the new technology when doing the optimization for the cost for the GPU. So in general, I want to know the trend currently happening for that side and what is the possible ways to shift across different type of servers, cloud, and in general, I want to just understand it. Also, like I don't understand 50% what you're talking about. It's too technical for me. Sorry.
Maybe we can level it up
Right.
from that perspective. So I was thinking, okay, it might be good. Like I think it was useful for me to understand. Okay, this is what we would use, but we also want to be able to communicate it to like users or CFOs why pick. So like selfishly, we would go to a customer and say the reason why you want to run your models or to use your agents on us is because we do these things. So maybe what would be the level up that you would say, and what's the expected, since we're talking enterprise, what's the cost savings transparent to all the other stuff that they would actually realize by using this?
Well, let's dive into the enterprise and CFO side. I
Yeah.
wanted to answer the cash question.
Yeah.
One of the really big places you can save is you can quantize the model down,
Yeah.
and the accuracy decrease is very low.
Yeah.
Even if you go from a full floating weight 16 to FP4, FP8.
Yeah.
And nowadays, you can also do KV sharing between different quantization versions. And I think it just got released last week. And now, it's by Ellen Cash.
Oh.
And now you can share KV
Between the quantized models, you're saying?
on the same model,
On the
but
model.
different quantizations that you might be running.
Oh, I
And-
see. Okay.
So now your pre-fill and decode, which you might decide to run on different quantization, even the network between pre-fill and decode, you can quantize that even more and aim to compact or
Yeah.
compress it up later on. And the cost savings on just quantization are very immense.
Yeah.
So I think putting it into perspective on if you're using an open source stack fully
Yeah.
from the model to all these optimization layers, and a lot of this is driven by research that is going on with the last year or two.
Yeah.
You can save, so we were running these numbers internally as well. An average company of 1,000 engineers who are spending average amount of cost on Claude, which is
Yeah.
like maybe 5 million input tokens, 250 output tokens a day.
Yeah.
Their monthly cost is in high hundreds of Ks
Yeah.
or millions of dollars.
Yeah.
And just by using open source models,
Yeah.
with no real optimization on hardware,
Yeah.
it can go down to 100 or 200K.
Yeah. I've heard
And-
similar things.
And that's without good placement
Yeah.
or without any fancy optimizations.
Yeah.
And when you add all those fancy optimizations, even when you're running on your own cluster,
Yeah.
so a lot of the, if you're talking about big enterprises, they're already running everything on their own cluster. I think the biggest issue is privacy. They
Yeah.
don't want API providers getting all this data.
Yeah.
So they're running it on their own cluster.
Yeah.
And our placement strategy, just by TP, PP, DP, which are different types of parallelisms,
Yeah.
and which place to put it on, whether to use the spot market or not,
Yeah.
and balancing between the risk, you can save anywhere from 40 to 50% cost.
Yeah.
Pretty easily, even if you're already on an open source stack.
Yeah. Wow.
And that's kind of unexplored. And
Yeah.
I actually came across this company, we came across this company yesterday. It's called EigenAI. A group of PhD students were working on, they made AWQ, which is a quantization technique. They got acquired by Nebius for $700 million yesterday.
Oh, wow.
And their whole thesis was better placement on
Really?
open source hardware. So that was a good motivation to see that the cloud provider, neoclouds, their margins are already very thin
Yeah.
when they're running it on APIs,
Yeah.
on their own hardware.
Yeah.
And cutting it down to even 2x, to
Yeah.
3x, it's millions of dollars.
Yeah.
And that was, the whole strategy was, can you put training and inference on the same set of hardware, and can you balance between the two? So if someone is doing open source in this sense, in their own enterprise, I think a better way to put it is you can easily save at least 50%
Yeah.
of the money that you're already putting in by just better placement.
Yeah.
What do you mean for the better placement? What is the current placement for the enterprise? What could be the better placement?
For example, you are, let's pick a big enterprise, let's say you're Uber, okay?
Okay.
And internally, you're gonna have different clusters. This is coming from some conversation we've had with many people.
And the different clusters in the same server or different server?
Different, you have some reservation on your own hardware, you have some reservation on cloud, on different AWS, GCP, and your computer fragmented. Now, internally, to submit a job, let's say you're just doing one job, these companies are doing anywhere from dozens to hundreds of jobs at the concurrent time. For just one job, from all the hardware resources you have, now you want to pick, hey, which GPU do I run this job on? And when I run it on some GPU node, how do I split this job? Do I split it vertically, horizontally? How many times do I split it? Which user request goes to which GPU? That adds up to hundreds of variables. And now you need to do this not just for one job, but dozens and hundreds of jobs that are going on. And manually it's not possible. So a lot of these companies today, I think Ray is being used by a lot of people. And for Ray, you can submit a job, and Ray lives on top of Kubernetes within a single cloud, single cluster, even though they might be working towards this multi-cluster routing. But you have to specify the hardware you need. The user has to manually, and then Ray will pick it for you. There are some moves towards letting our planner decide what hardware do we need. So NVIDIA is working on some within Dynamo for a small set of cluster.
Yeah.
And what hardware should I choose for this job?
Yeah.
But they're still in very early days. And people are using on SM utilization. I'm not sure if you guys have heard, but last couple of years, utilization have been around 40%, industry average.
Yeah.
So they're missing out on 60% of the GPU because of worse placement. Additionally, one more example is, your job for coding task might need a bigger context window, but for a normal Q&A chatbot, you might need a smaller context window. Your just input and output tokens are different. That completely changes the way you want to split a model on a specific set of GPUs. So currently, a lot of the work is manual, and then supported by Ray and Kubernetes. But we want to find an automatic way that, hey, users can submit many jobs. We will take care of the life cycle of those jobs. And new jobs are coming in, old jobs are being finished. How do you manage the best placement at all times? And how do you converge to an optimal placement? Currently, what does optimal placement even mean? It really depends on what the job types are and what hardware is even available. So there's no real answer. There's no ground truth to what the optimal placement is even. And it's totally dependent on each person's cluster.
So what is it that you optimize on those 40-50%? Like you said, if you're really running open source models, right, and then go and cut for like 40-50%, is it because you need less GPUs for that amount of jobs you need to go through, even though you run open source models? Is it like on the electricity bill because you run more efficiently? Is it less entropic tokens?
So less GPUs in terms, and not just less GPUs, but what type of GPUs? And even on the type of GPUs, in what fashion? When we say we were running open source, no one really knows how we're splitting the model in these GPUs. The new models are 2 terabytes in size.
Yeah.
And these GPUs only have capacity of hundreds of gigabytes. You need to split the model onto different set of GPUs.
Yeah.
Those strategies, manually benchmarking them is very hard.
Yeah.
And no human can adaptively do it every couple of seconds for all jobs in the cluster.
Yeah.
So you need some sort of way of doing it. And additionally, now instead of having to use just H100s for my specific job, can I split the same job with H100s, maybe A100s, some AMD GPUs, some TPUs, some inferential GPUs?
Yeah.
If I can do so, I can number one, take advantage of spot instances.
Yeah.
I can totally get 90% cheaper if I'm in the
Yeah.
cloud. But even if I own my own hardware, each of these GPUs are different. And
Yeah,
actually,
we can repurpose things that are kind of like, instead of like ending the life cycle, we can
Correct,
actually extend it. That's,
and these GPUs are not bad because, and bad is also what does it mean to be bad or good?
Yeah.
It just totally depends on a job.
Yeah.
So you can And one of the metrics we track for is dollar per token, which is a function of like watt per token.
Yeah.
And we want to try to optimize for all these things.
Yeah.
So sorry, on the Uber example that you made before, so it was I'm ignorant in the matter because I don't know it was the hardware. So Uber has its own hardware, and you basically make sure that the hardware perform better, and so that they reduce the cost.
And not just specific to Uber, a lot of these big enterprises,
Yep.
they have a mixture of their own hardware and also rented compute
Yeah.
on either from a provider reserve, on spots, and et cetera, et cetera. They have different quotas.
Yeah.
And they want to juggle many different jobs at the same time. And hey, can I take one job away from my on-prem one and put it onto spots because it's weaker SLO and complete a job that's stronger SLO in different GPUs? A new job just came in, it's an emergency. It needs to be done faster. My other job will not hurt too much, or will still need a SLO if I place on worse GPUs.
Yeah.
It's managing between incoming jobs, outgoing jobs. For example, if you guys are gonna provide a bunch of model APIs in the future,
Yeah.
there will be many different APIs they will provide. You will not provide
Right.
just one model.
Right.
Based on the incoming request of users onto let's say you guys are providing 3 APIs,
Yeah.
one might have more load at a time than the other.
Yeah.
So we want to give it more resources than the other. So we don't want to statically place resources.
Yeah.
I know Kubernetes handles some of this, but Kubernetes doesn't do the parallelization strategies. It
Yeah.
has no notion of it to do adaptively. And we're building on top of this.
How do you set, for example, the optimization for this? I'll give you an example. And I'm curious to see where the context plays in it for non-text modalities. So we were talking to someone that had enterprise workloads that they couldn't get really well satisfied because it was voice. And throughput is mostly where people are optimizing for. But really, they care about latency. And so they're willing to pay a tax on the throughput to get better latency. How would that be set in our environment where we might have a mixture? Like we might be trying to go and increase like what we want to do on the voice side, but even the voice pipeline will always have text because it's going to take someone's inbound voice, they might transcribe it and then put it onto voice. So we're going to be running this mixed optimization. So we're not going to have we're not optimizing for a single variable,
Correct,
right? So how do you set that? Like, what's the framing and how do you measure that so that you're optimizing for something that's delivered at, like...
So we don't take each variable as a variable in itself.
Yeah.
We have 6 main things we care about, 7
Yeah.
main things. We care about latency,
Yeah.
which is we care about TTFT, teapot.
Yeah.
We care about dollar per token. We care
Yeah.
about throughput.
Yeah.
And we care about throughput for prefill and decode separately.
Yeah.
And for online jobs, you can assign each one of them weights. For example, I care.
How do you specify the job? Is there some tag that we need to associate with that?
Correct,
Because
correct.
I'm willing to sacrifice latency on all the text and batch stuff,
Yeah.
but anything that touches voice, we are willing to drop.
So each job has a label. It's
I see.
online.
Okay.
It has a scope. Maybe it's a chat bar, it's a Q&A, et cetera, or maybe it's voice. And we want to, and it depends on what hardware you have as well. Only certain hardware can fulfill
Yeah.
voice applications or
Yeah.
online applications.
Yeah.
But depending on that, we can set, hey, for online, for example, in general online, I
Yeah.
don't really care about throughput. I don't really care about dollar per token. I mostly care about teapot and
Yeah.
TTFT.
Right.
So you want to jointly optimize for just teapot and TTFT mostly.
Yeah.
For bash, it's the other way around. So in our case, we have this mixture of variables. Some of them we want to optimize, maximize, or some of them we want to minimize.
Yeah.
And we want to perform this joint optimization.
Yeah.
And we actually released a pretty mathematical white paper a couple of days ago as well. We'll publish it in a couple of months. And it describes which weight to give
I
to
see.
online and batch jobs and how they can live together in the same cluster at the
Interesting.
same time.
How about, what's your take on multimodal things? Is context really just something where it's text, or do you believe that there is context is useful in a voice pipeline where there is some sort of text? I'm just totally, that might not be relevant at all, I'm just curious, because we were talking about the complexity of text because people are speaking, they're being asked things, there has to be a go to text, and then it goes back to voice, pipeline. Is context useful in that, or it's not?
So in our applications, what we see with our clients, ultimately it comes down to text.
Yeah.
Like, even when you're orchestrating like tool calls or script calls and so on,
Yeah.
again, the tool, it's a description.
Yeah,
Right?
I see,
The agent
I
needs
see.
to read and be like, okay, you need to
I
put
see.
this MCP or this API.
I see.
That would be a great question for our friends at 11 Labs.
Yeah. Right.
Because, I mean, I think number one for voice AI and everything, we
Yeah.
specifically are not positioning there on the voice part,
Got it.
exactly because of this latency
Yeah.
side.
Yeah.
So, yeah, for now what we see, it's mostly like voice and then it goes down to text when it
Yeah.
gets to the model level.
Yeah. Where do you draw the line in terms of your context management and memory? And where should that sit as an abstraction for somebody who's running inference or agents? Like, there's a lot of standalone things. We're trying to say, is there a way to just abstract and just say, hey, have a harness, this thing just takes care of what you need. Can you maybe help disambiguate, context management versus memory versus how much somebody needs to explicitly be setting those things up? Because it feels like, for me, there's been an evolution of where do people go, especially for long-running jobs you talked about, and also things that have like a lot of context.
Yep.
And at the same time, your output needs to have a lot of accuracy. So insurance, finance, things like that. Maybe you can share a little bit about.
Totally. So, as I was mentioning before, context, the first standard context was basically drugs.
Yeah.
Right? So like filling documents so that your LLM can reply within rich data.
Yeah.
It was like the idea of an agent a year and a half ago. And then memory became also essential for like the whole finance industry. There's, for example, here in SF there is Zero.
Yeah, that's zero.
Some of the biggest clients
Yeah.
like banks and so on for the privacy issues.
Yeah.
Right? So like having everything stored like kind of on the in-house memories and so on.
Yeah.
Then memory came, and thanks to Connect, maybe a bit more around like ontology.
Yeah.
So like interrelating things away from RAGs, more like into like embeddings. And again, here our friends at Cogni also with they play an amazing role, right? So it's like really interrelating data from different documents. Where we move is more towards like, it's not just about what the agent needs to know from like a text point of view, but it's about when you ask an agent to act. When you ask the Notion agent to create a database, right? Sometimes it creates an inline database, sometimes it creates a different type of database because it has 150 tools. You need to orchestrate which one to call, right? And then if you take the example of consumer agents, some of our clients they have like 150K monthly active users, and their customers, their agents, do more than like 50 turns per session.
Wow. Okay.
So every agent creates new skills to manage different type of behavior for a specific agent. And what do you do with that? You either put it in the system prompt and you consume it every time, even when it's not needed, or you put it outside, right? So going forward, we do see like the whole context layer about like different niches, like who provides the memory, who provides like the catalogs, and then like who provides the whole runtime. It brings everything together to now it's called looping engineering, improving agents, all the sort of things that ultimately makes the agent tailored to each user, to each of us.
Okay, cool. All right, I think we're hitting time, but we really only have two guests here. Any questions? You guys kind of get personalized attention because there's no one else here. So, is there something that when we have folks that are kind of, like you see they've got clients and customers and stuff, it's a valuable perspective from an investor perspective, but also what is it that you're building? You're building agents for your clients? Is that kind of your...
It's infrastructure for agencies building agents to others of workflows.
Okay.
It's one place where they can spin up instances quickly and then assign it to a client and let them